For most of human history, humans believe the universe must have a center, a single place where everything began, a cosmic origin point similar to the center of a circle. This idea feels natural because it mirrors how we understand our everyday world. Cities have centers. Maps have middles. Even stories tend to begin at a specific place. It seems reasonable to assume the universe itself must follow the same pattern. Yet modern astronomy has revealed something far more unexpected. According to our best measurements, the universe may have no center at all. There is no unique central point, no preferred location, and no edge where space itself ends. Wherever you are in the universe, whether on Earth, in another galaxy, or billions of light years away, the large-scale structure of the cosmos appears essentially the same. This simple observation has profound consequences for how we understand reality. When scientists say the universe is expanding, many people imagine an explosion, with matter rushing outward from a central point into empty space. This image is intuitive but deeply misleading. The universe did not expand into space. Space itself expanded. To understand this, it helps to abandon the idea of a single starting point. A useful analogy is the surface of a balloon. As the balloon inflates, every point on its surface moves away from every other point. No location on the surface is the center of the expansion. The center exists, but it is not part of the surface itself. In the same way, the universe expands in all directions simultaneously. From within the universe, every location appears to be at the center of expansion, even though no true center exists within space. This concept leads to a fundamental shift in how we interpret the Big Bang. The Big Bang was not an explosion that occurred at one particular place in space. It was an expansion of space everywhere at once. Every region of the universe was once extremely hot and dense. There was no single point where the universe began while other regions remained empty. If the universe has no center today, then it likely never had one. The Big Bang happened here and there and everywhere simultaneously. This idea challenges our intuition, but it is supported by multiple independent observations, including the cosmic microwave background radiation, the distribution of galaxies, and precise measurements of cosmic expansion. The cosmic microwave background, often described as the afterglow of the Big Bang, is one of the strongest pieces of evidence for a centerless universe. This faint radiation fills the entire sky and appears nearly uniform in all directions. If the universe had a central origin point within space, we would expect to see strong directional differences in this radiation. Instead, it looks almost the same no matter where we observe from. This uniformity suggests that the early universe was remarkably homogeneous, reinforcing the idea that no location was privileged over any other. Astronomers also observe that distant galaxies are moving away from us, and the farther away a galaxy is, the faster it appears to recede. This relationship, known as Hubble's law, is observed in every direction. Importantly, this pattern would appear the same from any galaxy. If we lived in a distant galaxy billions of light years away, we would see our own Milky Way moving away from that location, just as other galaxies appear to move away from us now. This symmetry is a cornerstone of modern cosmology and leads to what is known as the cosmological principle. According to this principle, the universe is homogeneous and isotropic on large scales, meaning it looks the same in every direction and from every location. The absence of a center naturally raises a deeper question. If the universe has no center, does it have an edge? And if it has no edge, Does that mean it is infinite? The answer is not yet known. A universe can be finite without having a boundary, much like the surface of a sphere is finite yet has no edge. If you travel far enough in one direction on a sphere, you eventually return to your starting point without ever encountering a boundary. Similarly, the universe could be finite but unbounded, or it could be infinite, extending endlessly in all directions. Current observations suggest that the universe is at least much larger than the portion we can observe. Light has only had about 13.8 billion years to travel since the Big Bang, and beyond that distance, regions of the universe may exist that we can never see. This limitation defines what scientists call the observable universe. Beyond this boundary, information has not had enough time to reach us. Yet the absence of observation does not imply the absence of existence. The universe may continue far beyond our cosmic horizon, obeying the same physical laws, and containing structures similar to those we observe nearby. Whether finite or infinite, the key point remains that no single location holds a special status. There is no cosmic center from which everything else radiates outward. The idea of a centerless universe can feel unsettling. Humans naturally seek reference points and anchors. We want to know where we stand and how everything relates to us. For centuries, Earth was believed to be the center of the cosmos. Later, the sun replaced Earth as the central object. Then the Milky Way was considered central. Each step in scientific progress has pushed us further from the center, not because we are insignificant, but because nature does not organize itself around human perspectives. The realization that the universe has no center represents the ultimate extension of this pattern. Yet this realization does not diminish the importance of observation or understanding. In a universe without a center, meaning does not arise from position. It arises from relationships, patterns, and laws that apply everywhere. The same physical principles that govern distant galaxies also govern the atoms in our bodies. The same expansion that separates galaxies over billions of years also defines the large-scale structure of space itself. In this sense, being located anywhere in the universe is enough to witness its fundamental behavior. There is also a subtle symmetry in a centerless universe. Every observer sees the universe unfolding in the same way. Every location is equally ordinary and equally remarkable. The absence of a center removes hierarchy from space itself. No place is cosmically superior, and no place is fundamentally excluded. The universe does not revolve around any single point, yet it remains coherent and intelligible through universal laws. Perhaps the most remarkable aspect of this idea is that a universe without a center can still be understood. Despite its vastness and apparent indifference to location, the universe follows patterns that can be measured, described, and predicted through observation and reasoning. Conscious beings can uncover the structure of a cosmos that does not privilege them in any way. In doing so, the universe becomes aware of itself, not through a central point in space, but through countless observers spread across its expanse. In the end, the absence of a cosmic center does not leave us lost. Instead, it places us fully within the universe rather than at its center. We are participants, not anchors. Wherever we are, the universe expands, galaxies drift apart, and time continues forward. From any point in space, the same story unfolds. And in that shared story, the act of observing, questioning, and understanding connects us to everything else, even in a universe that has no center at all.